This is day 2 of the law of cosines, which is also going to bring in another area of a triangle formula called Heron's formula. Let's start with reviewing the law of cosines. If you look at this first example and you draw a triangle, you can see that we're given a side setup. So that tells us we're going to have to use the law of cosines. We need to find the missing angles. So let's start out by finding angle C. So we're using the alternative form where the cosine of C equals a squared plus b squared minus c squared over 2 times a times b. Again, you guys should know how to plug this into your calculator all at once. I'll write it out one more time. You know you have to do inverse cosine because it's an angle, and you're going to, a parenthesis will automatically open up on most of your calculators. If it doesn't, you need to type in a double parenthesis, and we're going to put our numerator in one parenthesis, close it, then we divide, and then we open up our parenthesis for our denominator and use your times button to multiply everything in the denominator together. Close the parenthesis for the denominator and then close parenthesis for the whole thing. And then that should give us that angle C equals 92.9 degrees. Remember, if you start with the law of cosines, let's stay with the law of cosines. So let's find angle A next. So you're going to do cosine of A equals b squared plus c squared minus a squared all over 2 times b times c. Typing this into your calculator, you get angle A to be 38.6 degrees. There are going to be times where if you start with the law of cosines and you switch to the law of sines, you will still get the same answer. But because of the ambiguous case, you don't know when you're going to get the right answer and when you're going to get the wrong answer. So I always just say if you start with the law of cosines, you stay with the law of cosines. Then to find angle B, we can use the fact that triangles add up to 180. So adding up the other two and subtracting from 180 gives us that angle B is 48.5 degrees. Do a quick check. The smallest side was A. The smallest angle was A. The largest side was C. The largest angle was C. So our answer makes sense. Example 2, we have a story problem. We want to approximate the length of a marsh. To do this, a surveyor who's starting here at point A walks 425 meters to point B. Just like the airplane problems, when the surveyor was walking this way, he is now at point B facing this direction. So when he makes his turn is going to be outside the triangle. So he makes his turn of 65 degrees and he walks 300 meters to point C. Your triangle is always going to have 3 vertices and 3 sides. So we want to approximate the length of AC. So we want to know this length right here, which I'm going to call B. To find that length, we need to find angle B first by subtracting 65 from 180 because we have supplementary angles. And then we're going to use the standard form, and we know that B squared equals A squared plus C squared minus 2 times A times C times the cosine of angle B. I'm going to plug this in all at once into my calculator by hitting the square root button first because I want to solve for side B. And when I plug that into my calculator, I should get 615.14 meters. And that's the approximate length of the marsh. And that makes sense because it's opposite the biggest angle. The new formula today is another area formula for a triangle, but we're going to use this formula when we have a side-side-side setup. This formula is called Heron's formula. And again, with this formula, angle A is opposite side A, angle B is opposite side B, and angle C is opposite side C. You can see that Heron's formula is the square root of S times the quantity S minus A times the quantity S minus B times the quantity S minus C. A, B, and C are lowercase, so they're the sides of the triangle. S in this case is 1/2 of the perimeter. A plus B plus C is the perimeter, and then you divide that by 2, so S is 1/2 of the perimeter. So the only time you're going to use Heron's formula is if the directions actually say find the area of the triangle. So your triangle has lengths of 43, 53, and 72. You don't have to draw a picture. First thing you're going to do when you're finding the area using this formula is find S. So you're going to take A plus B plus C and you're going to cut it in half. Because S is half the perimeter, that's 84. Then the area is going to be the square root of 84 times 84 minus A times the quantity of 84 minus B times the quantity of 84 minus C. Again, I would type this into your calculator all at one time. When you do this, make sure if your calculator, when you hit your square root button, opens a parenthesis, don't close it after you type in the first 84. If your square root button puts a parenthesis right here, you won't close that parenthesis until the very end. So type it in exactly like you see it on this screen, and you should get for an area 1,131.89 square meters. It's area again, so your meters are going to be squared. Again, the only time you use this formula is when it's a side-side-side setup and you're asked to find the area. You can pause the video to try this next example, but this next example wants you to approximate the area. So you know that the sides of your triangle are 200, 500, and 600. So since we have a side-side-side setup, we're going to use Heron's formula, and S is going to be half of the perimeter. So I'm going to add up all the sides for the perimeter, cut it in half, and S ends up being 650. So to find the area, you're going to do the square root of 650 times 650 minus 200 times 650 minus 500 times 650 minus 600. You can subtract those if you want, but to be quite honest, I just plug it in exactly like you see it right here. That way I don't mess up on any subtracting, and I get my area to be 46,837.5 square feet. These last two story problems, we're going to draw a picture and determine if it's better to use the law of sines or the law of cosines. In example 5, it says, from a certain distance, the angle of elevation to the top of the building is 17 degrees. So here's my building. Here's my ground, I'm standing right here. 17 degrees is pretty small, so I know I'm further away. And the angle of elevation is formed with a line of sight looking up and a horizontal line. At a point 50 meters closer to the building, so now we go closer to the building, 50 meters. The angle of elevation is still looking up, but this time that angle is this angle right here, and that is 31 degrees. So we have a triangle over here, and then we have a triangle on the left. We are trying to find the height of the building, so we want to know that distance here. The given side, which was 50 meters, is in this triangle on the left. So we are going to have to use this triangle in the left and find the shared side between the two triangles. It's the easiest one to find first, by using the law of sines. I can't use the law of cosines. Let's find some angles and we'll talk more about why. I know I have a 31 degree angle, which means if I subtract that from 180, I get 149 for that angle. And then 17 and 149, subtract that from 180, and I get 14. So when I look at this, I have an angle side angle setup, which tells me to use the law of sines. X is opposite the 17, so I'm going to do x over the sine of 17 equals 50 is the other side that we know, and it's opposite the 14. Remember, with the law of sines, the angle always goes with the sine. So now I cross multiply, and I get x to equal 60.4269. Since that's not my final answer, I'm going to go ahead and round it to 4 decimal places. Now I move over here to the black triangle, and x, which I just found, is opposite the 90 degree angle. So I'm going to do 60.4269 over the sine of 90 equals h, which I'm looking for, over the sine of 31. Since that is a right triangle, I could also go back and use SOHCAHTOA. When I cross multiply, I get h, which is the height of my building, to be 31.12 meters. This last example is probably the hardest picture to get. We have a tree that stands on a hillside of a slope of 28 degrees from the horizontal. So we have this hill, here's the ground. We have this hill right here that's 28 degrees. Then we have a tree that's on the hillside. So there's my tree on the hillside. You know, I always have to form a triangle, and that line that I just drew in will form a right angle with the ground. From a point 75 feet down the hill, the angle of elevation to the top of the tree is 45 degrees. Since they told me it was an angle of elevation, I know that my point 75 feet down the hill has to be formed with the horizontal. Here's my horizontal, so that means this has to be my point. And if I'm looking to the top of the tree, then this angle right here is 45 degrees. So that's the trick. You need to understand that an angle of elevation is formed with the horizontal. So if I continue that line down, I have a big right triangle and I have a little right triangle. And they did tell me that this side length right here is 75 feet. So I want to know just the height of the tree. So I am looking for this. In this particular problem, I think what I am going to use is, I think I'm going to use the right triangles. So I'm going to use the small right triangle first. The small right triangle has the 28 degrees, the 75 feet, and the 90 degrees. And I'm going to find this distance. So to do that, I am going to say x is opposite the 28, so I'm going to use law of sines again, and the 75 is opposite the 90. When I cross multiply, I get x to equal 35.2. And that's feet. Now what I'm going to do is I am going to use the big triangle, which I have highlighted in red, but I'll highlight it again. The big triangle and if this is 45, I know that this angle has to be 45. So I have a 45, 45, 90 triangle, and I was going to try and find y, but I was going to call y this side. I don't think I have enough information to do that. So I'm going to have to switch gears here. And what I did in the beginning was not wrong, but I don't think that's going to help me in this particular problem. So I looked at it a little bit differently, so I'm going to go back up here and scratch that out. And I'm going to focus on this triangle that has side H that I'm looking for. I just showed you that this angle is 45 degrees. I know that this side is 75 and it's opposite that 45. And I can find this angle down here, this angle right here, by taking 45 minus 28. And that angle is going to be 17, and that's opposite my H. So this method actually gets me my answer a lot faster than the other way I was trying. So if I'm looking for H, it's going to be H over the sine of 17 equals 75 over the sine of 45. The first method that I tried wasn't wrong, and it did give me some insight into how I ultimately was trying to solve this. So it's good that we think about every scenario possible with finding these sides and angles. Now if you cross multiply, you get the height of the tree to be 31.01 feet. Remember, we found this 45-degree angle up here by using the big right triangle. It was a 45, 45, 90. Hope this helps. If you have any questions, make sure that you email me or come in for some help.